Experiment 1, looking at precision of measurements. This is part B2 of the experiment. We're going to start off with the same 10 milliliter graduated cylinder we weighed in the previous part of the experiment. So take the mass you got for that graduated cylinder in part B1 and make sure it's written as the mass of the graduated cylinder, if not tared, in part B2. If you look at the graduated cylinder, look closely at the markings. The markings show every whole number with 4 lines in between the whole numbers. So if you break down a milliliter into 5 even divisions, that means each line is 2/10 of a milliliter. The best estimate we can make with this device, therefore, for volume is to the nearest tenth. Right? Its precision is limited to the tenths place. So I'm going to take some water, and I'm going to start filling up the graduated cylinder with some water until I get 7 milliliters. So I fill it up until the meniscus is sitting right on top of the 7 milliliter mark. Now make sure you're putting it at eye level. So if I position this properly, it's hard to do with the camera, but you can see the curve at the bottom of the surface of the liquid is just touching the 7 milliliter mark. So I'm going to take this now, and I'm going to take the 7 milliliter sample, and I'm going to take it over to my balance and weigh the weigh the graduated cylinder with 7 milliliters of water. So I've now gone over to where my balance is. I've got my test tube with my 7 milliliters of water, and I'm going to place it on the balance and get the mass of the test tube, or the cylinder and the water. So you'll record that for trial 1 for the mass of cylinder plus water. By taking this number and subtracting the mass of the empty cylinder, I can calculate the mass of 7 milliliters of water. What I'm going to do for the next part of the procedure is I'm going to repeat this process for a total of 6 measurements. I will dump out the water, refill it to 7 milliliters, and then reweigh the cylinder with the water. So I'm not going to bother showing you every single step of that process. I'll pause and restart the video whenever I've dumped out the water and refilled it, and I'll show you all the measurements that you can record for your data sheet. So I have emptied the cylinder, filled it up with a second sample of 7 milliliters of water. Let's weigh that. So that is the mass for trial 2, mass of cylinder and water. Trial 3, third sample of water. Let's get the mass of cylinder plus water. Now notice these numbers are not coming out exactly the same. Even though the balance is able to go down to the 3rd decimal place, we're seeing variation before then. All right. Think about what's going on with the precision of the devices we're using, the precision of the graduated cylinder versus the precision of the balance. So that's sample number 3. Trial 4. Trial 5. And finally, our 6th and final trial. So now with all those measurements, you should be able to calculate the mass of the 7 milliliters of water for all 6 trials, then calculate the average mass for the 6 trials, and then make a comment about the precision of the mass measurements. How precise were the numbers and what was limiting the precision of those numbers. So that's it for part B2, precision of measurements.